Hello, and welcome to the walkthrough for worksheet number 8 of our regular tutoring section. We're pretty much like more than halfway done with the class right now, so good job at making it this far. We are going to be continuing today with the actual data structure portion of the class, and we are talking about B-trees here. We talked a little bit about B-trees in the last worksheet, and this is going to be another kind of mechanical problem, so hopefully this is the kind of one that you can just do over and over again until you know how to do it permanently, and then it's free points on any exams. This is also the first video in this series I'm recording at night. You can tell it's night because I have my mood lighting candle here and my chamomile tea. You can't see my window, but it is night. Anyways, let's do the actual question now. So basically in this first question, you're just going to be given a B tree. It is this B tree basically, and we're just going to insert some nodes into it. I have redrawn the B tree here just so that I can kind of erase things and move things around as I do this. So we're inserting 18, 38, 12, 13, and 20 in the B tree. So here's how I've drawn the B tree. Notice that unlike the diagram here, I have drawn little kind of null tails at the bottom of each of these. You could call them leaf nodes if you want. This is just how I draw it. This is how I learned to do it. You see people do it like this a lot. And it's also a good reminder that the reason these are called 2-3 trees is not because they can have 2 to 3 nodes because they can't have, or 2 to 3 items per node because they can't have 3 items in node. It's because they can have 2 to 3 children, right? So this node is a 3 node because it has 3 children, even though it only has 2 things in it, which I think is a bad naming convention, but that's just how it works. Anyways, so let's start by inserting 18. So to insert anything into a B tree, we're basically going to start with the basic BST insertion process. And we are always going to insert at the bottom layer of our B tree. We're going to go until we hit a null, and then we're going to insert at that node. And then we're going to push things up if we deem it necessary. So 18 is going to be kind of the most simple operation we could possibly do. We are, just like in a BST, going to start at 8. We're going to say, okay, 18 is bigger than 8. So we're going to go to the right. That's going to bring us to this 14 node. We're going to say, okay, 18 is bigger than 14. So we're going to go to the right again. Bring us to the 15 node. We're going to say, okay, 18 is bigger than 15. Go to the right again. That is a null. So we're going to basically back up and put 18 in the node that contains the 15 already. And we are going to put it to the right of the 15. One final thing we're going to do is we're going to add another null child, basically this node, right? Because now there are 2 numbers. This null here represents the numbers less than or greater than 14, less than 15. This is between 15 and 18, and this is above 18, bigger than 18, right? Okay, so that's the first one. That's the simplest case. Now we're going to add in 38. So 38, we're going to do the same process. I'm not going to walk through this step by step because you can probably do it on your own. Basically, we're going to go all the way down to the right again, and we are going to put 38 into this bottom node, right? So I will do this to make the node a little bigger. We have 38, and we have an extra child. Now our node is overstuffed, right? It is a 2-3 tree, but this one has 4 children, so our node is overstuffed. So what we're going to do is we're going to push the middle element of this overstuffed node up. Notice that even though we put a 38 in here, we're going to push 18 up because it's the middle element. That's just going to give us nicer balancing. So here's basically what you do. This node needs to go up into this node, right? So first thing I'm going to do is I'm going to just erase the 18 here, put it up here. Keep in mind what that means, right? Now, this node up here is going to become a 3 node because we have this child here, which is going to represent the numbers greater than 8, less than 14. This new child we just added, which is going to represent the numbers between 14 and 18, and this rightmost child, which is going to represent the numbers bigger than 18. Whoops. Okay, so you might notice that there's a problem here. 15 is not bigger than 18, and this node needs to be split up. Okay, so where does 15 go? So remember, we pushed up the middle element, we push up the 18, which means everything to the left of that 18 is going to belong to basically this new node, because it still has to be to the left of 18, which is now up here, and everything that was to the right of 18 has to be to the right still. So we are going to split this node in half, basically, like that. And then this 15 is going to connect to here. This 38 is going to connect to here. right? This looks a little weird, but the reason I want to do this is notice that we didn't have to get rid of any of these like null children, right? We had an overstuffed node. There were 4 things, and we split that into 2 nodes that each of which have 2 children now. Just to make things a little cleaner though, I'm going to rewrite it. I just wanted to do that so that you could see we don't actually need to change the children. We just need to change where the parents are. Okay. So that's what happens when you add in 38. You push up the 18. Great. Now let's put in 12. Okay. So we're going to do the same BST process as usual. To the right at 8, to the left at 14, and then it goes to the right of 10, 12. We get an extra child there. Nothing else special has to happen. 13. Okay, so 13 is going to do the same thing. And 13 is going to end up right here inside of this node. We'll create an extra thing. And now we have an overstuffed node again. So what do we need to do? We need to take the middle element, which is the 12. We need to push it up into the parent node. And then we need to split the remaining 2 elements into 2 separate nodes, each of which have 2 children. Okay, so I'm going to put the 12 up here, right? That means that this node up here gets an extra child. That node 2 notices overstuffed, but we'll worry about that later. Then remove the 12 here, split this node in half into 2 nodes, right? And then just connect it like that. Okay, notice that this still makes sense, that all of our binary search tree properties still hold. Everything is still in order. 10 is less than 12, so it's to the left. 13 is between 12 and 14, so it's in the middle of those 2. Okay, but what you've noticed, or what you may notice now, is that this node is overstuffed. So what do? We do the same process. We take the middle element, which is 14. We push it up, which means we're going to get an extra child here, right? And then we're going to split this node into 2 nodes, each of which has 2 children. And this is going here, and this is going to go here, right? Again, looks a little weird just because, that's what happens when the diagram goes. But notice how we split this up. Now we can insert 13. Okay, the final thing is we're going to insert 20. So 20 is just going to follow all the normal BST properties. It's going to end up here to the left of 38. We're going to have an extra child, and this is what we end up with at the end. So some big things to notice here. Notice that we only split nodes up when they become overstuffed. So when there are 3 things in a node, notice that we always add the new element to an already existing node. This is unlike a regular BST where you create a new node as like a child. We always add to an existing node. And notice that this tree kind of builds from the bottom up, right? A normal BST, you're going to start at the top and you're going to get nodes that go progressively deeper and deeper into it. This one, everything starts at the bottom and we only extend, push up to the top once we absolutely need to. This is one of the main runtime benefits of this algorithm too, right? This tree is always going to end up with a log n height. So we're going to avoid that spindly case of a BST where everything is in order because we're always going to balance things and push them up only when we need to. Anyways, that is the mechanical part. That is the first question.